Hello, everyone, and welcome to the Smart Work Zone Case Studies webinar. My name is Said Hanaf Moshed, and I'll help facilitate today's webinar. This webinar, the third in a series of 5, which will represent an overview of NCHRP data integration sharing management for transportation planning and traffic operations. As a quick reminder, at National Operations Center of Excellence, we offer a variety of resources to support the transportation system management and operations community. You can go to NOCO's website to browse through links for TISMO resources and news. Previous webinar recordings and case studies can be accessed from there. Now I'll cover a few logistics for today's webinar. We are recording this webinar and the recording will be available on NOCO's website. All the attendees are encouraged to stay engaged by using the Q&A feature for questions and chat feature for comments. These are both on the bottom of your screen. We have a question and answer session at the end of the presentation, so if you have any questions, we encourage you to enter them in the Q&A area as they come to your mind at any time. Also, please feel free to enter your name and agency in the chat to say hello to your peers. Now I will hand it over to Kelly, Senior Director for Transportation at AEM Corporation, who will be moderating today's webinar. Kelly, the floor is yours.
Thank you, Anaf. Thank you all for joining today. This, as Anaf mentioned, this is a series of webinars that we are doing on NCHRP 08119. The title is Data Integration, Sharing, and Management for Transportation Planning and Traffic Operations. Next slide, please. So just a quick overview of the project. Or the agenda for today. So I'm going to get a little bit of background on the project and the layout for today's webinar, and then talk about the forthcoming report. And we have 3 panelists today to present. So first off, Mike McGurran is going to talk about the work zone product that we did for NCHRP 08119 and give a little bit of information about that, which is part of the forthcoming report. And then we have 3 panelists, Ross Scheckler with Icones Products, Skylar Knickerbocker with Iowa State, and Jacob Brady with Arcadis IBI Group. And then we'll have some time at the end for question and answer and a panel discussion. Next slide. So a really quick overview of the NCHRP 08119 project. So this project has been going on for a little over 4 years. It started back in September of 19, and we are wrapping it up at the end of December. It was a multi-phase project that involved a phase of information gathering and identification of products. It's a little bit different than some NCHRPs where there's one guidebook or a report. Our charge was to identify areas where there were needs for data sharing, integration, and management to support state DOTs. And so that phase 1 was to do a broad review of the literature and talk with agencies about areas where they could improve data sharing, integration, and management, and identify products that we could develop. Phase 2 was documenting that information into a web-based format, which I'll show you in a minute. And then phase 3 was the development, testing, and deployment of these standalone products. Next slide, please. So these are the 11 standalone research products that we developed. I won't read them all. But today's webinar focuses on the use of smart work zone devices for work zone data feeds, and in particular 5 case studies. We do have another webinar coming up next week on a product we developed called Linker AT, which is about a network conflation tool. That's next Thursday. And then the following week, we have a webinar on December 12th on our 2 freight products. And then we did do a webinar a couple of weeks ago on 2 shared mobility products, a shared mobility data resource guide and a sensitive shared mobility guide. You can go to NOCO's website and check out that recording from that webinar. And then, as I mentioned, we developed a website, and that you can find that at data.transportationops.org. And this is all of the information that we gathered in phase 1, and it's cross-referenced and linked by different data application areas. There'll be information on our research products and also additional resources. And I'll just mention that all of these standalone products are going to have been brought into one under one cover, a comprehensive final research report that after we finish up, we'll go through the TRB publication cycle and be available sometime next year. So this is just giving you kind of a sneak peek at what is to come. So with that, I will turn it over to Mike McGurran, who is the author of the Work Zone case studies product that we developed. And he will give a little overview of that and then introduce the individual panelists.
Thanks, Kelly. Yeah, I'm going to start off with sort of a brief introduction about what our Smart Work Zone, just to set a level base. I'm sure a lot of you on the call already know about this, but bring everybody up to speed, and also on the Work Zone data exchange specification. But before we get started on that, I thought it'd be good to get an idea more of who all's in the audience. So we have 2 quick poll questions. If you could bring up the first poll question about what type of organization you're all representing. So if you could just take a second, fill out what type of organization that you are working for, or if you're a student or what have you. We'll give that a little bit. Okay, and off, if you could close that poll and show us the results. Thanks. Okay, so it looks like we have a good mix with a lot of representation, almost half the people on the webinar from state agencies, and then lots of people who are representing various types of private contractors or consultants, with a mix of others as well. So if we can close that then on off and open up the second poll question. Great. So this is looking at trying to get an idea of what experience your organization has with smart work zones, whether you're using smart work zone devices and the data exchange feed, just one or just the other, neither, but you have plans to implement, or you don't have plans to implement, or if you're like a student or an educator, that it's probably not applicable to your organization. So you can just take a few seconds to answer the second poll. Okay, if you can close that poll out and see the results. Great. Okay. Good. So we have I'd say a pretty even distribution here, with folks who've have experience and familiarity using both smart devices and the data exchange. Number of folks that use smart work zone devices but don't have a data exchange specification. Number of folks that are planning to implement, some that don't currently have any plans to implement. So great. That gives us a good idea of who the audience is and the mix we have in the audience. Okay, if we can close that and go to the next slide. So part of the issue that we're trying to address is that work zones are dangerous places, and they're also, of course, places where we have a lot of delay. This data is from 2021, where we had basically over 100,000 work zone crashes in 2021, and that's similar, and I'm sure in the last couple of years as well. And those 106,000 crashes produced an estimated 42,000 injuries, killed almost 1,000 people. About 300 of the incidents involving fatalities involve trucks, and a number of pedestrians, which can be just plain, pedestrians walking along, or the work zone staff themselves being killed in work zones. So it's a dangerous area. We want to make them safer. We want to make people more aware of work zones, as well as to reduce delay. Next slide. So one of the issues if you don't have smart work zone devices, you have planning data where agencies have planned out where work zones will be occurring, but that's often fairly coarse data. It may describe a large project, so it'll say, okay, over the next X number of weeks, we're going to be working over these miles of roadway. But in reality, of course, at any given time, only a portion of that roadway is actually being worked on. So you don't have that granularity from the broad planning data. And similarly, you have static message signs, work zone ahead that we've all seen, and those are very useful. But I'm sure we've also come across, where there's a work zone ahead sign and we drive by and there's no closed lanes, there's no workers present, there's no work going on at that given time. So it's not always up to date. There's certainly a work zone going on there, but it may not be going on the day and time that you drive by and see the work zone ahead message. So the idea is with smart work zone devices, we can have real-time sensors, communications with data coming from those sensors, and link that up with computer technology to get that real-time information. And that can be used both to inform traffic management operations, as well as to inform drivers and travelers of real-time work zone conditions. Next slide. So by doing this, by providing this real-time information, we increase safety, both for drivers and construction workers, and we reduce delays. And the three characteristics that let us do that is these smart work zone systems provide real-time data, they provide reliable data, and they're automated. And that's important. There's been a lot of studies that find if they take a lot of work to set up, it's not a priority among construction workers. Things don't get switched on. They don't get set up properly. So it's a key to have these devices work as automatically as possible in order to provide this data. Next slide. So today's webinar, I should point out, is going to talk about smart work zone devices feeding data back to traffic management operations or out to third parties who then provide it to traveler information systems. It's not going to focus on direct communications from, say, a smart device on the roadside just down the road a ways to a portable dynamic message sign. Those are also very important, but the overall scope of this project was on managing data, not the local data. So there's another whole aspect of smart roadside devices that the report doesn't really address. Okay, next slide. And then if this data came in 50 different formats, each one developed separately by each state, with different types of information being provided by every state, and all this information coming in 50 different formats, people aren't going to use it. So the idea was to develop a standard, a specification that would have a simple open specification that would provide that common format, what type of data is being provided, a format for that data. The idea is by doing that, it would be broadly adopted and as a result, save lives by making this available. And that's the purpose of the work zone data exchange specification that I'll talk more about and our panelists will also talk more about today. Next slide. So the data flow for how does this work with the work zone data exchange specification? The first is you need to get the data back from the smart work zone devices using a common specification. And that was actually the second step historically in the development. The first step was developing, if you look just down below that, published in a common format. The first part of the work zone data specification we developed was what's that common publication format so that state agencies could provide this data out to third parties, and then that could get delivered into devices that, or screens and displays that are directly in roadway users. But then it was seen that they needed to also have a common specification for how do these smart devices talk back to traffic management operations. And that was also now included in the work zone data exchange specification. A lot of the original work was based on work done by Massachusetts DOT, and Jacob later today is going to talk about what MassDOT has been doing in their systems. And a lot of their preliminary work then became the basis for the work, that part of the work zone data exchange specification. Next slide. So the current status of that specification, the US DOT keeps a feed registry to have links to all the different agencies that are currently providing feeds. They have 25 different agencies currently up there on their feed registry, providing work zone data exchange conformant data feeds. The current version of the specification is version 4.2, which came out early this year. And again, I think Ross is going to talk more about what's been going on since then and the future plans. But that version was the last version created by what was called the Work Zone Data Working Group, directly under US DOT sponsorship, with input, of course, from private industry, state DOTs, et cetera. That work's been turned over to the Connected Work Zone Initiative that ITE and SAE are leading. And again, Ross is active in that area, as are some of our other panelists, and can talk more about that later in the day. Next slide. So now I'm going to turn to the forthcoming report and give you basically a sneak peek at what type of information in much more detail in the report, of course, it will be provided in this forthcoming report, which focuses mainly on 5 case studies in 5 different agencies. Next slide. So as I mentioned, the report is built around 5 different case studies. The objective is basically to give a snapshot on the state of the practice. There's a lot of different variations. Different agencies are in very different places regarding their maturity or their use of these devices. So it gives a look at what's the state of the practice across the country on the smart devices and on providing data feeds. And the primary target audience are basically public sector agencies that are looking to deploy and implement these devices and these data feeds. Next slide. So looking at the content, what's in this report, first, just like I did today, it gives an overview of smart work zone devices and the work zone data exchange specification, obviously in much more detail than I've gone into today. Then it goes into each of 5 separate case studies. It looks at the Minnesota DOT, the Kentucky Transportation Cabinet, the Regional Transportation Commission of Southern Nevada, the Iowa DOT, and the Massachusetts DOT. Next slide. After that, there's a section that looks across all 5 case studies. What are similarities? What are differences? What are some lessons that we can learn, both from their individual deployments and by looking at across the board at all 5 of them? And then there's an appendix in there. It's important to recognize with respect to the work zone data exchange specification and feeds that comply with that this didn't exist in a total vacuum. There's been traveler information feeds since the very early days of ITS, well over a decade ago, that have provided information, including information on work zones that have been out there. So how does this relate to the work zone data exchange? How do they relate to one another? There's also a commercial company called HosAlert that has been working on providing data feeds for years on emergency vehicles, both traveling and located on incident scenes. And they're expanding their services to include work zone data exchange information in their feed. And then Icone's Products, Ross's company, is working also on something called real on-time accurate data for work zones, where the concept is take that data across the board directly from the devices and create one national feed that's available on a subscription service. It may be a long time before all 50 states separately implement their feeds. There's issues on funding and who pays for the equipment versus who benefits. And so this is aimed to address some of that by integrating one common feed from all the devices and providing revenue back to the equipment makers and providers in return for their providing this data to the feed to try to make it a win-win in terms of a business model. Turning back to the 5 case studies, which are the core of the report, for each case study, it describes what's been done in the past, what's the current status, and what's planned for the future regarding these areas. What were the project's goals, some of the lessons learned, what were the particular technologies used, what types of data were collected, and what types of applications were deployed using this data or plan to be deployed using this data. Next slide. So looking at each of the 5, Minnesota DOT, they have one of these existing traveler information systems that I've mentioned that's out and available to third parties. Like a number of states, they use a platform called CARS to provide event management and road condition reporting. They're working on converting that or have worked to convert that CARS work zone report into a work zone data compliant feed. Also at generating those feeds automatically to require less staff time, less management intervention to create those feeds directly from smart devices and vehicles. And they're also working on an app for smartphones that workers would carry in the work zones, where they would check in when they showed up at the work zone. The work zone data exchange feed, one of the data fields it has is a worker present field. That if it's true, that means there's absolutely some sort of device or system that is identified that workers are actively working on that work zone, and they're looking at a smartphone application that would then be used to populate that information. Then looking at the Kentucky Transportation Cabinet, what they've been doing, they're doing a lot of work on big data analytics, ingesting data from smart work zone devices. Their focus has been more on looking at monitoring the speeds in the work zones, crashes in the work zones, both for crash management, but also where are there incidents, how can we learn from that, how can we improve on that. And they are also, when this analysis was done, we're working on implementing a work zone data exchange feed at the time of this report was written. Next slide. Then the Regional Transportation Commission of Southern Nevada, that's a sort of an umbrella organization that works with a number of local organizations within that region. That region includes Las Vegas. One of the unique things that they had worked on was contracting with a private company. There's a couple of companies that do this. They use dash cams that are in cars and fleet vehicles and automated machine vision of those dash cam images to recognize basically work zone devices, cones, barrels, traffic signs, arrow boards, and then they geolocate that from the GPS that's with these dash cams and report back where there's work zones based on the camera data. And this can be data from equipment from this company that private car owners have bought their equipment and agree to let that data be used, or from fleet management vehicles, as I mentioned. The image on the right is a snapshot of a particular day showing all the active work zones in the area that had been identified through this automated image recognition system. They also worked on a very comprehensive and detailed work zone ITS specification, comprehensively laying out what they wanted to see from every type of work zone device in every work zone in the area was their desired goal, how that data would be reported. And they also are providing the data to the Haas Alert Safety Cloud system that I mentioned. Next slide. Massachusetts DOT. What they going to talk a lot about their Smart Work Zone Manager application. They have Smart Work Zone devices in the field. That gets pulled together, combined with data from their planning systems, produces a work zone data exchange feed. And as I mentioned, they were really the pioneers with developing a standard. Originally, it was just for Massachusetts for the format to come from these smart work zone devices back into their systems. They developed an open mass-specific API, and that became the basis now that's rolled into the National Work Zone Data Exchange specification for those systems to report. Then the Iowa DOT, they took sort of a different approach from what Southern Nevada did. Their goal was, let's start small, let's start very well defined, and then as we show success, then we can expand from there. So they began with automated collection of the beginning location of active work zones by using smart arrow boards at the beginning of work zones where there was a lane closure, initially just in an interstate highway. And then as that became successful, they expanded that to other roadways, and they're expanding that now to other devices, as Skylar will talk about later. And the data coming back from those devices are integrated with their ATMS. And a little diagram on the right sort of shows an example where they're integrating their planned work zone planning data with the actual real-time data. And that little box on the left shows that, the planning data may say Interstate 80, both directions, intermittent lane closures, over the following directions. The road will be intermittently closed various times on weekdays. So that's the plan, but but obviously not that whole section is going to be closed all the time. It'll be intermittent closures. So the real-time data gives you what sections are actually closed at any given actual time. And so they combine those information together. Next slide. So then it goes into the cross-cutting summary of analysis. 4 of the 5 systems do have work zone data feeds. The 5th one is planning to implement one. So that was common across all 5. All 5 use smart arrow boards. 4 continue to use them. The other one wants to pick up using them again, but they had funding issues. They were using them in a pilot project. The pilot project was successful, but they didn't have the money to continue to use them at the current time. And then there was a mix and match of other technologies that was used among the different agencies. As I mentioned, there was sort of a compare and contrast. Iowa started small, was successful, it grew and grew and grew. Southern Nevada sort of tried to take a huge bite of the apple all at once by developing a very comprehensive approach, laying out a lot of requirements on their member agencies and on the vendors providing equipment. And the agencies really haven't bought into that. They have not really gotten a lot of buy-in from that with trying to take that large chunk approach. I mentioned, Minnesota used arrow boards, but wants to get back to them, but continued. Funding's been a challenge. One of the issues is who benefits and who pays. The benefits are mainly seen by traffic management operations and safety operations, but the cost for deployment of the devices is the construction and maintenance offices. So there's been sort of a mismatch, and funding has sometimes been an issue that's reported. Next slide. Okay, so now I'm going to turn it over to our panelists. The first panelist is Ross Scheckler. Ross is the president and CTO of Icon Products. Back in 2005, the state of New York asked his company at that time, Calmer Research, to create a simpler, more robust traffic monitoring system based on principles that were being used in the truck telematics industry. That resulted in the creation of the current company, Icon Products, and a series of work zone ICS products that are based on simplicity and affordability. Mr. Scheckler has advised NASA, the US DOE, the US DOE, the EPA, the Army, and the Air Force. He's been a guest lecturer in the Aerospace Department of Syracuse University and has served as the president of Iowa State University's Industry Advisor Council. He's currently the co-chair of the Connected Work Zone Standardization Project that's picked up the Work Zone Data Exchange specification, and he served as the vice chair of the American Traffic Safety Services Association's Innovation Council, as well as the chair of the Work Zone ITS Subcommittee. He's been a member of the Work Zone Data Exchange since Ariel Gold at Federal Highways first opened the conversation back in 2017. So with that, Ross, I'll turn it over to you.
Thank you, Mike. Let's go to the next slide, please. Short and quick here. This is a complex world that's moving really fast, and honestly, it's hard to put a set of slides together that stays current on a week-to-week basis. But the big news here, really, for a lot of people in the room some have been very active in participating in the development of work zone standards. Some are kind of watching from a distance. And what we're seeing right now, and part of the story is that this story is really coming to a head. We very much have a maturing industry around the generation and dissemination of work zone data. We started out with, honestly, a bunch of us started out using whatever standard we needed to talk to Waze. Then 2017, 2018, Ariel Gold got a bunch of us together and said, okay, well, let's put together under JPO a data exchange standard, very, very roughly modeled after the transit data exchange standard. So it's not at that time, it wasn't a standard, it was a spec. WZDx version 4.2 now is a specification for the exchange of data in two different scales, in the overall work zone data exchange, and also in the subset of that, which is a device feed. But understanding that specifications don't necessarily have the infrastructure under them to have a multi-year life. As we finished up version 4.2, the FHWA contracted with ITE, Neiman and Ashto to turn this specification into a standard. And over the last 18 months or so, we have been working on the documentation and the language behind a standard for exchanging data on work zones. This is being accompanied by standards on incident response and standards on other things of that nature, all supporting one another. It's kind of a painful process. A bunch of us, who worked on pulling together a WZDx standard or a specification, didn't know why we needed to turn around and go back and make a standard, but it all makes sense now. We're well along on that process. As a matter of fact, I believe we're about a year ahead. And so those standards, those specifications that are necessary for people to know how to do business together and talk, passing data back and forth, those are in place now. The construction industry is rapidly adopting connectivity. Most states are under some sort of a trial program. There's private sources of the field data available. The organizations like mine that create equipment that that monitor traffic control activity are all spinning up to be able to connect all their equipment and to share data amongst each other and make it available to the public sector as well as to the transportation industry. And what we feel a landmark movement in this is the North Central Texas Council of Governments stepped out last year to write a comprehensive contract to acquire data to support their traffic operations center. And they put that contract together in a manner that allowed them to support all of the public entities in their region. And they put together in a purchasing co-op so that other entities could use the same contract mechanism to bring in the private sector data from the devices. And then beyond that, there's also an existing and growing engineering support services marketplace out there. There's a dozen different companies who can come in and aid agencies in putting together a WZDx feed and then managing the process going forward. It's a healthy industry to teach you how to use the data, to how to get the data in a timely fashion, manage it, understand that these three devices actually correlate to the same work zone that was planned 2 months ago, and then push that out as a combined data feed. All of that's in existence right now. it's all very new, but it's maturing very rapidly. And something that started just a few years ago is so desired by both the public and the private sector that's becoming a rapidly mature and one of the really bright spots on how to use data to make your operations work better. Can we switch to the next slide, please? So on the standards development effort, this is a AASHTO, ITE, NEMA led effort with a whole bunch of public and private members sitting on the committee. I have the honor of co-chairing that with Raj from Florida DOT. And we're well along in the process. We are at the point where we've had user comments of a proposed draft standard. The user comments have gone through the committee and the friends of the committee, and they come back and been reviewed. We just voted to accept those right before Thanksgiving. That's being put ready to go out as truly public user comment period that will be coming in the next couple of weeks. There will be, with those back and reviewed and incorporated, there will then go on to a test phase. The committee is looking for sites where we can test the standard, make sure that what we're doing is being done in the field and the standard align properly. And then, realistically, by third quarter of 2024, we should have a fully published standard. And then we will go into a maintenance process for the years going into the future. There's already a list of more things that we want to add to this the standard. There's more things happening. There's more people, more activities coming in. Next slide, please. So this is a little bit of an old graphic, but this is for those of you who aren't well versed in WZDx. I encourage everybody to just put in your Google search bar GitHub WZDx. The site is actually really solid. An immense amount of work has gone into this. There was 2 or 3 years of meetings almost every week with 100 or more people in many of those meetings. Most of the people who are on this webinar right now. We're now at the point where I believe there's 22 or 26 entities that are publishing a WZDx of one size or another. So this map is a little bit outdated. And we are also seeing 2 or 3 national publicly available device feeds to support the WZDx feed. And with that, I would think it's worth just going to the next slide and just talking through one time exactly how the 2 feeds support each other. On the left, the top, every agency has some sort of a work plan, planning data that typically populates the agency's 511 system. And that's your project is scheduled. This is the name of the project. This is the road it's going to be on. Here are the contact points. Here's the type of work it's going to be. That can all be put together in the WZDX format and published in a common format that anybody can go and pick up, public sector, private sector, and be aware of that planned work that is going on in each of the jurisdictions. But as we all know, and as Mike mentioned, that's planned work. And planned works means that we're going to pave somewhere on US 20 in Iowa in the month of May. But we don't pave 24 hours a day, 7 days a week, and we don't pave in the rain. So the reality is that the plan is not always up to date and up to the minute. And yes, much credit to Massachusetts DOT. 7 or 8 years ago, they started to ask for standard for information from traffic control devices in the work zone. And it became obvious immediately once we started WZDX that planned work was going to need to be supported with real-time information from the field, source of truth, so to speak. And so there is a second feed, which is subsidiary to the WZDx feed, known as the device feed. And this is a standard for the basic traffic control devices, how they're monitored and reported on to support the planned activity. Think of this as the arrow boards, the message boards on your job, the portable signals, markers for the locations of things. These are the items that are reported on in the device feed. And that information supports through a software algorithm the location of an arrow board that's on the side of the road pointing left and active right now is associated with a planned project. That project can be then updated, and that updated project with real time, yes, the lane is closed right now, updates the WZDx feed and is passed out to the world. That's the basic structure. One of the things that we've learned, and once again, credit to Iowa for getting a saturation of equipment out there very quickly. Basically, every arrow board in the state of Iowa is a connected arrow board now. And we've worked a lot with Skylar and his team at Iowa State University. And just looking at the kind of data that's out there. Because one of the things that happened in Iowa is they went through, the DOT worked with the industry, met extensively with the ATSA chapter, and said, we want to do this. And spent about 18 months getting everybody ready to do it. The industry was fine with it. Everybody's playing by the same rule book. Everybody's going to have the same cost. Costs went up a little bit on the rental of an arrow board. And the state announced that October 1, all interstate jobs are going to change. And they meant it. And the industry believed them. And within 9 months, every arrow board in the state of Iowa was converted over and ready to go. And what that means is all the rental arrow boards out in the private fleet got changed over. So not only did all of the state jobs become connected, all of the county and municipal jobs use that same fleet of arrow boards. So all the jobs, all the lane closure jobs in the state of Iowa in a matter of a year became connected jobs. And it's been very interesting. Now that there's a marketplace for this, and now that the equipment's out there, we're seeing not just the state work show up and be connected, but everything is connected. Utility work, municipal work, county work. And one of the things that we're learning is easily 90% of the work out there is not on the state network. It's on everything else. There's far more data out there than you would expect from looking at the state schedule. There's a lot more activity. And I think once we see all the utility work come in, we're going to see that 95% of the work is stuff that we didn't know about. It was never in a 511 system. That's one of the real positive takeaways on this. And we're seeing that grow rapidly. We're seeing other data sources show up. Iowa is one of those places where we're starting to see construction activity data show up as a avatar for workers present. We're seeing the construction equipment move around. We're seeing dump trucks show up. And that's, clearly that there's workers there and doing things. New data sources are going to continue to emerge, but this is a really rapidly growing space. And it's going to be something that we're all going to have to work together to make it so it's a viable, not just a viable technology area, but a viable business area. And as long as everybody's benefiting from the safety, from the economics, from the improved operations, this is going to continue to grow, because this is one of the things out there that really helps people. So with that said, I've taken through 4 slides and made them last 20 minutes. I apologize for that. I would like to hand this off to Skylar. The work that Iowa State University and the C-Tree group have done has been fantastic. And he's got a good story to tell. Thank you, guys.
Perfect. Thanks, Ross. Yeah, next up, as Ross mentioned, is Skylar Knickerbocker. Skylar is a researcher and the co-director for the Real-Time Analytics and Transportation, or REACTOR, laboratory. He works primarily in the areas of traffic operations, maintenance, and safety, including data analytics, data visualization, and big data management. In his role, he's led various research projects for the Iowa Department of Transportation, the Minnesota Department of Transportation, and the Federal Highway Administration. And with that, I'll turn it over to you, Skylar.
Perfect. Thanks, Mike. So I want to start and just kind of segue off of some of the things that Ross mentioned at the end, and that this has been a large number of groups and organizations that have been part of this, from the WZDx at the national scale to just in Iowa. It's been a lot of coordination with vendors and manufacturers like Ross and others, our contractors that are actually in the field deploying these devices for us to actually get this data. And then with a whole host of other data integrators and systems on the back end for how we actually use this data and distribute it out through the WZDx. So today I'm going to try to give you that story of why we did this in Iowa and what motivated us, and then what we're actually doing to use both the WZDx device feed as well as the WZDx feed. So if you can go to the next slide, and probably just skip my introduction slide to the next one. So really what motivated us in Iowa was this urge to know, what are all the lanes closed right now? And we ask ourselves that question, and the problem that Mike and Ross both said is we don't always know where all these are, and if there are, it's very inaccurate. So if we wanted to be able to get this out to the public, what steps do we need to take to be able to accomplish this? And next slide. And then just reiterating what Ross and Mike said is there's inaccuracies in the data. I often go to various state DOTs whenever I'm out traveling and presenting, and it's pretty easy if you can see both cameras and the work zones that they put out there, that there's inaccuracies. Here in Iowa is just a screenshot of one that I was able to find within a couple minutes, where we said we're going to reduce it to 1 lane, and the project was going to start at 9 p.m. But we're almost an hour later and there's no lane closure in sight. So how do we not lose the confidence in who we're providing this data to say, okay, we actually know whether that work zone is actually out there because we verified it, or it's just estimated because we're planning on working out there, but we don't know it's actually out there or not at this time. Next slide. And the challenge is we know that we can't ask our field staff to be able to provide this information. The motivation, or the kind of the comments a few years ago, or 10 probably years ago, was, well, let's just give them another form to fill out and tell us whenever they're out there working. But they're more focused on the concrete being laid, the rebar, getting tickets and different things like that, that this isn't their main focus of the traffic control and being able to have accurate information. So if you go to the next slide, where we then transition to is looking at ways that we can automatically collect this and using more of an IoT approach, where we have different devices and sensors out there that we know where they'll be placed, and that we can get that information off those devices to have confidence and verification that the work zone's actually out there, and improve the overall accuracy of our data. So using things like smart arrow boards that have been mentioned multiple times today, using other devices like these pins that go in cones, or panels that have electronic communication, or even just our AVL trucks that have this location information provided in them, where we can get this information of where they're at, what's their status, and we can have confidence if it's a work zone or not. And this is just a sampling of the devices. I'll talk about a few other ones that we're testing out at the end. But next slide. Where we really focused was on the smart arrow board deployment. And Mike said that we started small, and really the reason we started small was we knew that this was going to require commitment from our contractors, and it's going to require them to procure resources and be able to buy these devices and build up their inventory and fleet. So that's where we started on just the interstates and wanted to test things out with just the interstates and then further expand that to all projects in 2022. The other reason we started with the aero boards is because it really doesn't require any training or changes in the field. The people in the field are still just flipping the switch to what the pattern is, and then we just start getting that data on the back end to the DOT. And then the other nice thing was that we could modify all of our existing inventory, and it wasn't requiring all the contractors to go out and buy brand new aero boards. They could still use the aero boards they have and just adding on a component, which makes it smart to be able to communicate with us. Next slide. And then I like to throw this one in there. Really the only difference between the aero board, and I've already mentioned it, from a non-smart aero board versus a smart aero board. If you click the slide, it will show up communication. It's really just communicating from those devices to the DOT, so we know actually where those devices are located and what's the pattern on there, so we can have with confidence where the work zone's at. If you go to the next slide. And unfortunately, we started this effort before there was the work zone data exchange device feed. So we could only have dreamt of having a WZDx device feed at that time. So what we did was we actually developed our own kind of homegrown smart aeroboard protocol is what we called it. And that's what we use to give to the vendors to say, here's the data format that we want. And it's nearly identical for the most part in the to the WZDx device feed. But it was really kind of starting to lay that groundwork and really along the lines of what MassDOT was doing to really generate that device feed and get that aero board data in a standard format, regardless of what manufacturer was providing that aero board. Next slide. And so this is just a map that we give our inspectors, because again, as I mentioned, there's real no difference between a dumb aero board versus a smart aero board. And so we wanted to give our inspectors the ability to quickly see and verify that it is a smart aero board. So they can simply open this map, verify that they're seeing the location information from the aero board, and then that gives them confidence that it is a smart aero board and that they're meeting the specification that we require, or the standard for providing these aero boards on our work zones. We've ranged from typically 90 to 140 aero boards at any given time across the state, with the definitely peaking in the summer months, where we have those active aero boards across the state. Next slide. Now that talks about all of our devices, and I'm going to start to transition now to the actual work zone information, because ultimately it's great to get this data and to be able to have confidence that we know where the work zones are, and it's used throughout the DOT. But really our goal is to get the information to the driver so that we can alert them ahead of time that there is a work zone ahead, and giving that confidence to the third parties as well, that we know that there's a verified work zone. So next slide. And how we've accomplished this is through our work zone data exchange. We received a demonstration grant in Iowa to create a WZDx, and really the two main points that we did through the demonstration grant was we first created WZDx based on our existing work zones in our ATMS. So it was a more fully featured WZDx that was provides the most latest data that is entered into our ATMS by our operators. And then the second part of our effort was to integrate these smart aero boards that I was talking about. So we can take that planned work zones that our operators are already submitting, marry up the smart aero boards that are associated to those work zones, and produce that WZDx feed that has the verified information of where those work zones start. Next slide. And this just summarizes kind of the benefits that we see of having the WZDx plus the smart arrow boards. Whenever we have an arrow board associated with a work zone, we show that the location is verified in the WZDx feed. So a third-party consumer that is taking this data knows that we have high confidence that there's a GPS equipped device out there that's collecting and providing that information used to update it. The system is also set up that if that arrow board leaves that work zone or goes outside of the extents of the work zone, then it gets disassociated with the work zone, and that work zone will go back to its estimated status or whatever it would have been if there wasn't an arrow board located there. So we still have the ability to show that estimated information, but supplementing that with the arrow board information. And ultimately, our goal is to have just improved safety and mobility through our work zones by being able to communicate to drivers most effectively what's out there on our roadways. So next slide. This is just kind of a peek behind what the operators see within our system. We do not have it automated at this point. We just have a manual system where the operators will enter the arrow boards just like they normally do. But now in that little red dash box, you can now see a smart arrow board option. So it's a one extra box that they can do to select an arrow board. And once they assign an arrow board to that work zone, as I mentioned before, it'll continue to update that work zone with its location. And if it's a reoccurring work zone where they work tonight from 8 p.m. to 5 a.m., it'll continue to follow it as they move that arrow board on and off the job and show it as a verified whenever it's actually out there and on the roadway. Next slide. And this is just a map. The map on the left is showing our 511 website, and the map on the right is showing that same arrow board dashboard that I showed previously. As you can see, the arrow board is being used to update the location within our 511 website. And then recently released about a month ago, if you go to the Iowa DOT's website, you'll start to see these little green check marks on all of the work zones. Anytime there is a green check mark on a work zone, that indicates that it's verified by a smart device. And it also, if you click on the work zone, it will provide that additional note there, shown in the top left corner, saying it's verified by a smart device. And if you click on that, that'll give you a little more details about it. This is public facing, so we had to remove some of the technical aspects of it and just be able to give them the basic information of what it is. But it's just another way for us to communicate out the work zone information to a different audience beyond just the WZDx, but using the same system on the back end. Next slide. And then this one I just threw in showing that what the WZDx feed actually looks like. So you can see highlighted there in green is where I've been talking about us verifying that these work zones are out there. So that's the primary field that's being updated or changed from estimated to verified whenever we do have a smart arrow board associated to the work zone. The one thing we are missing is we don't have verification of the end location, so we still rely on what end location was inputted by the operators. But that's an effort that we're still trying to focus on and get better data to get better devices out there to collect that sort of data. Next slide. So I just wanted to highlight a few of the challenges and lessons learned that we had. The one challenge that we had was, even though we had this standard protocol of how we wanted to communicate device or data from the smart arrow boards to us, not every agency or manufacturer provided the same level of feed in a sense. There were some that required put security credentials behind it, or more advanced security credentials, which required additional effort. There were others that were rate limiting how many devices that we could request at a time. While there were others that just provided a data feed that was open and available for us to easily download. So we had to work through all of those things to get those integrated, but it was just one challenge that we had to overcome as we're doing this. Next slide. The other challenge we had was, because we are manually assigning these arrow boards to the work zones, there's no our initial expectations that operators would see them on the map and be able to associate them to a work zone. But that wasn't really how it was actually being handled. So we identified a need for setting up alerts. And so now we have alerts that are set up where if an error board turns on and it's not associated to a work zone, and it's on a state roadway, then we provide that alert to the operator saying, hey, here's an error board. If there is a nearby work zone, we recommend what that error or work zone it should be associated with. If there's not, then we just tell them maybe a work zone should be created because of that. We also have a variety of other checks that are done. I think we have 8 or 9 in total, from integrating error boards if they're not integrated to providing alerts if we have an error board associated to a work zone that's not showing up there. So we really needed this to help support the overall system. Next slide. For next steps, connected portable traffic signals are where Iowa DOT is focusing right now. I mentioned before for the error boards, we only dreamt of a device feed. Now that we're here and we have a WZDx device feed, that's what we're using. So it made our process a lot easier. We're updating our specifications now that will require a WZDx device feed for connected portable traffic signals. We're going to do testing next year and then start requiring them in 2025. Again, this long leeway is really just to give the contractors enough time to be able to start procuring the secure equipment for us to test it and really hit the ground running in 2025. Next slide. And this is just a slide showing all the different devices that we're also testing. We've been focused on the error boards and connected portable signals because they're easy and low-hanging fruit. But there's a lot of these other devices out there on the market that are going to be coming to Iowa and to other states where we can actually use those and integrate these into our data feeds and into our WZDx work zone feeds. Just a few to note are the portable rumble strips from Icon. They provide a box for you to locate those. There's things that go on the back of signs that whenever you set them down and whenever you put it up, you get a notification that the sign's been put up. So we're looking at that again, provide the start location for work zones where we don't have smart arrow boards. And then also just using our AVL equipment where we know where those devices or where those trucks are located. If they meet a certain criteria, we can safely assume that they're in a maintenance operation that we can then provide out through our WZDx device feed. Next slide. Yep, I think that's it. And so I'll pass it back to Mike and go with Jacob Brady.
Thanks a lot, Scholar. So our last panelist today is Jacob Brady with Arcadis. Jacob is a lead software developer with experience architecting software systems in the ITS, transportation, and work zone technology realm. Jacob manages their work on work zone software products, which was designed for the Massachusetts Department of Transportation and is now also used by the Florida Department of Transportation District 4. Jacob served as the co-chair for the Work Zone Data Exchange Specification Update Subgroup for over 2 years and was the primary implementer and reviewer of updates to the Work Zone Data Exchange Specification for the past 4 specification releases. So Jacob, I'll turn it over to you.
Great, thanks, Mike. Hello, everyone. We can go on to the next slide. I'm just going to talk about the work that we've done with MassDOT and the software systems in place to support taking in the work zone data and the device data and combining those and putting out data for public and third parties. So starting with some of the background on how we started getting into work zone data with MassDOT. So the original goal was that MassDOT has had smart work zone requirements in place for a long time, before 2017, when we started working with them to develop software to support them. And the limitations were that they had to use vendor-specific software to see those devices and got data in different formats from different vendors, and then didn't have a way to aggregate that data for reporting or a way to see all of the data at once or share that. So that led to going through the systems engineering process and creating a software platform called Workzone Manager, now one of Arcadis's software products, which was built for MassDOT to do that, to integrate with different vendor systems and provide a centralized store of the data for work zones. So throughout that development process, we learned about work zone data exchange when it was still in version 1, and then got involved in that. Me and Michelle Boucher at MassDOT and Neil Boudreau at MassDOT, who has put a lot of effort into this work that we've done, and on the WZDx in general, as Mike mentioned earlier. And so the work zone manager software evolved alongside the work zone data exchange specification to basically all the data concepts about how to represent a work zone and the language you use around like the fields that storing a work zone and how you represent a large work zone with multiple distinct linear segments and that kind of thing that the work zone data exchange defined, we integrated into the application. So then we came to have this MassDOT, the work zone manager software, which was based on work zone data exchange and could put out work zone data exchange. And you can go to the next slide. So a lot of the stuff that we've done has been similar to what Skylar was saying that Iowa did with getting smart device data, combining it with planned data, and then using that to put out a WZDx feed that has higher quality information, verified locations, and verified to be occurring at that time. So I'm going to talk a little bit more about sort of the software behind that and the data flow of the software. So the software that does that at MassDOT, and parts of it are also used in Florida District 4 and in Wisconsin, piece of the software, though not the whole flow that MassDOT uses. So it's a web-based application that has a mobile-friendly user interface, and it allows configuring, managing, and monitoring work zones throughout the state. So those come in from different sources, and you can also enter them directly. And so through that process, we get the work zone planned event data into the system. You can also see the field devices. So it integrates with all the device types defined in the WZDx device feed. So it's really simple. It means that if you have a vendor producing a device feed, you just configure the URL in the software, and then you can see all of the devices. So like in that screenshot, you can see there's a camera and a message sign. There's also error boards, of course, and location markers, and others. And so from one perspective, you have the viewing of all this data in a centralized place and storing of all the data in a consistent format for historical reporting. And so then you can also do reporting, run reports from historical data or about events that are upcoming to like create graphs and PDFs to share and help with planning. And so the software right now in MassDOT gets a lot of its data from another MassDOT system, which also provides data to Mass 511, which is like sort of a notifications platform that the events in that get entered through the DOT operators. And so I'll talk more about that in a bit, but that's where a lot of the planned event data comes from. But there's another way that can happen in Work Zone Manager, and this is the direction that MassDOT is working towards now, which is the Work Zone Manager has a link closure request system functionality where like either contractors or DOT staff, like resident engineers, can request via the system to do road work in a certain area. Say we're planning to do this here, we want to do it at this time and have this impact, and then other DOT staff would be assigned as reviewers and go through a review and approval process. So in that way, then all the work that is going to be happening in Massachusetts goes in through this system rather than relying on operators to enter something based on like maybe some other process that happened before the data got to the operators. And also leads to more consistent data with it all being entered according to WZDx, like from the terms used from the point it was entered, and also higher quality data because of the restrictions imposed by the entry form. And so then the last feature that's provided is the combination of the planned events with the real-time device data to do things just like I was doing about verifying the location or verifying the active status. So go to the next slide, please. So this is a diagram on the data flow with the inputs on the left, and then the work zone manager software system, all its components just broadly, and then what goes out. So for the 3 inputs to the system, there's manual entry using the web app. That could be through your phone if a contractor doing it. That's not the workflow that's in place in MassDOT right now, but it's supported by the software. Or it could be operators knowing that there's work there because they got notice of it a different way and just entering it manually in the system. Or it could be in this, again, this is where it's going at MassDOT, the lane closure requests, which are also entered via the UI, and then go through that approval process before becoming approved planned work, which would then be treated like events coming from other sources like MassDOT's notification system. So the second data source is the work zone vendor systems like Icon and Vermac. The work zone manager collects data from those via the WZDx device feed. So that's the field device data getting in. And then the last source is just any other work zone data sources that the agency has in MassDOT. That's their notification system where the stuff gets entered by operators. But this could be like a different lane closure system that then work zone manager integrates with to get the planned event data in. On the output side, we have the primary thing that this presentation is about, the work zone data exchange work zone feed. So that's the events in the WZDx format with verified information from combining with the field devices, and then also the work zone manager UI. So you can see everything about the devices and everything about the work zones, and have the option at MassDOT. They can just create read-only accounts and share those within the agency, or you can have the whole thing be public and it works sort of like a specialized 511 system, I guess, or it can send the data to 511, and MassDOT's also working on that with 511 taking in the WZDx work zone feed. All right, next slide. So for what's remaining and what we're working on now, the first is to get more data. So unlike Iowa, which has a ton of error boards already and access to all those, MassDOT doesn't have that much data. The only device data that they have right now is from very large projects, which there's only a couple active at a time, and then various other devices that just show up randomly, like Ross was saying, because they're not associated with like larger projects. So having the specifications in MassDOT change to require projects to include connected devices is the first step. And what the first step of that sort of large step is the major projects on state roads to include, or that meet some certain criteria as well, to include the start location marker, an arrow board at the point of the closure, and an end location marker. So then you have the full bounds of the work zone and the place where the lane is actually closed. So that's in progress. The next step is to do more automation. So the biggest thing about this is we want the devices to be associated automatically with the planned events and unassociated automatically, depending on, like, at the simplest case, if it's in the planned bounds or within some range of the planned bounds and the dates match up and the device recently updated and the event's supposed to be active like about this time, then the software would automatically do this. And the software is in place for this, but we don't have enough devices. We haven't done the testing process and actually tried it out yet to see how it's working and see how many devices we're actually getting to be matched. And the farthest next step of that is considering what to do when you have devices on like local roads where you don't have the planned event data. Maybe we want to look into like automatically creating like point events for those locations and saying there might be work occurring at this point. So the less stuff for the users of the system to have to do. We don't want people to, and there aren't resources right now at MassDOT for somebody to be like using the system daily and seeing that this device comes online and is near the work zone and having to manually associate it. There's also problems with that, with like, if the device goes offline and then comes back, you don't necessarily know if it's the same one, and then you'd have to redo it manually. So it would be easiest if that was automated by the software. So we were getting all of the benefits of the combined data without a user having to do anything. The third thing that we hope to get out of the system is to use it to gain more knowledge for future planning and about like just statistics about the work zones. So that's regarding improving the reporting capability and improving the use of the associated device data to maybe do like, if you have these kind of devices associated, we want to like do a design for what can we report on based on these set of devices that are there. And so working on the design of those reports and then developing that in the system is another thing we're working on. And then the last thing is improving data quality. And so that can be done through a lot of means. The major one we've identified so far is about changing the place the planned events get entered so that it's not via operators, via, I guess, secondhand learning this information that then they're entering into the system, and the user interface supports like putting in stuff that doesn't make sense, like direction, how the road affecting like all 4 directions for one roadway, or just like, it could be stuff as simple as like not putting the points on a road at all. So it's like, those kind of things can be improved by shifting the entry of the workzone information to be through the workzone manager, which then has more constraints over what kind of thing you can enter. And that's probably going to be done at MassDOT through having the request and approval process of the planned work be done also in the workzone manager. So those requests will get created there to start. And next slide, please. So that's it for what I wanted to cover about MassDOT's use of WZDx in the workzone manager. These are contact info for me and Neil. Next slide, please. And I'll pass it back to Mike.
Thanks, Skylar. That was very good. So we have a number of good questions in the Q&A feed. To the panelists, if you can, if some of them can be answered quickly in typing, that's probably good because they don't have all that much time left and they're good questions. The first question, probably Ross best addressed. Can you quickly illuminate the rest of us as to why the specification needs to be transformed into a standard? Ross, you want to comment on that?
Well, I think that's maybe the expertise of the standard development organizations, such as SAE or NEMA. But a specification in and of itself is not exclusive of other specifications that might fulfill the need. The standard is sort of a narrative on why are we doing this and what do we want to accomplish, where the specification is very directly, this is the way it must be written. Mm-hmm. So we're going to continue to maintain a standard that is, why are we communicating data about work zone activity? And of a subset of that is a specification that is WZDx. Okay. It's completely conceivable that there will be a different specification in a different world of computing and communications. The intention is for the standard to last, like many other standards, 20, 30 years, and the specification or multiple specifications modified as technology and understanding changes. And okay, I'm not a standards guy, but I get it. And the standards people who are, make their careers out of doing this stuff have beaten me hard enough that I now agree with them that we do need to have a very generalized standard so that we can then have one or multiple specifications come and go over time, but the standard remains the same.
Thanks, Ross. The next question is, will the states with existing and planned work zone data exchange feeds have to purchase the new standard next year in order to update their feeds?
I don't believe so.
Okay, thanks. Let's see, then next question, does the work zone data exchange address information security of the data in transit, or how is it stored for data integrity? Confidentiality, integrity, and availability are the three tenets for security. You want to comment on that?
Yeah, that's there are real issues of data rights and security. For the most part, though, we have to remember this is public stuff done for public reasons. We have big orange signs with flashy lights on them so that people see them.
Mhm.
You know, the intention is for it to be public. So the WZDx fee that maybe Iowa is sharing with the world is meant to be shared data. The issues actually lie sort of where the private sector interacts with the public sector. And one of my soapboxes is actually about the issues of personal devices and when that may be reporting a person or a truck is at a given location. When do we make that private information? How do we anonymize it? How do we protect it? One of the things that our company does is that for something such as a work truck, if the work truck isn't active, that data doesn't go anywhere.
Mhm.
That doesn't go out to the world. If the work truck is active, we assign a ID number to it, and we maintain that ID number and we share it to the world because the intention is if I'm turning my flashy lights on, I want the world to know I'm there, but I don't necessarily want the number to know who I am. If they turn the flashy lights off and then they turn them on again, we assign a different number to it so that you know that the connectivity can't be made between this truck was here and then an hour later it's at another place. There are those issues. They're not fully answered in the standard. We do have to address this going forward. This has been a hot topic of conversation within the group. I encourage everybody to participate in this because this is kind of where you run into issues if we use personal cell phones to identify that there are people there, or if we give somebody a vest that he takes home with him and then locates his house. There are issues here, but it's once it gets into the state and once the state's ready to publish it, if it got as far as the state, it was because it was turned on and the world wanted you to see it, and this is public data. But once again, encourage everybody to participate. I am really an evangelist on privacy, and we're doing what we can, and we're keeping the conversation going.
Okay, great. Next question, and several of them are being answered, and folks are typing in their answers from the panel, so please check the Q&A and appreciate that. The question says, great info, thanks so much. Ross or others, on the flow chart, could you just say a bit more about the role of third parties and give an example? For instance, I'm thinking of a use case where a work zone popped up, for example, emergency maintenance, and an approaching truck platoon needs to know ASAP. An agency immediately drops it into their system, goes out via the Work Zone Data Exchange feed, then what?
Well, so in the flow chart that I gave, the third party is a wide variety of users. It's Waze, it's Google Maps, it's also General Motors. It may be a trucking company, it may be something else, right? This is the third parties, and one of the things that's important there is until every work activity on the road successfully goes through the state, becomes a full WZDx, and every one of them gets published, there's going to be two routes to the third party. And one of the things that we are discovering is because of utility work, because of work from less sophisticated entities such as counties, that's never going to have a full WZDx feed associated with it, but people still need to know it. Mm-hmm. So the big stuff, the stuff that the state or the agency knows about and can put a full WZDx structure around, that's going to go out and be published as a WZDx feed, and General Motors and Ford and Audi and those will pick it up and share it. But that's about 5% of the data. There's a lot more data points and a lot less information on all of those utility jobs, every Time Warner truck that stops, every tree trimming truck that's in the middle of the road. That stuff needs to be marked too. But by the very nature of the ad hoc work, we're not going to be able to define a full WZDX feed with anticipated start date, anticipated end date, project ID, all those things that go into WZDX. Those aren't ever going to exist, but we need to get that data to the third parties also. So a lot of what's been done in WZDX is to provide continuity through events that happen and are delivered to a third party through multiple means. What the data that we pass to Jacob or to Skylar or to any of others as a equipment builder, that's going to go out and they're going to publish it, and that arrow board on the side of the road is going to be identified in a full WZDX feed. But it also may come directly from our company and go into General Motors. And they need ability to see from multiple streams all the work. That's how they're going to get all the work. And they need to be able to make sense of 3 or 4 streams of data that are talking about the same thing, and they need to understand where they agree and where there's new data. So that's why I point to the third party.
Try to get to one last question, then we have a couple wrap-up things. Last question: how accurate and precise is device location in work zones for reconstructing work zone characteristics in the event of a traffic collision?
I think most of the standards are 3 meters CEP.
All righty.
It's GPS, right? I mean, GPS is what GPS is. Most GPS is 3 meters CEP.
Mike, I think there's a question for Skylar for inventory of smart arrow boards, that one.
Well, yeah, I think I saw an answer that Skylar typed in, but it's still showing up, Skylar, as if you'd like to answer.
Yeah, sorry, I clicked the wrong button. I was going to type it in, but now it won't let me give the option. But Melissa, for your question on the smart arrow boards, there are retrofit kits available. I think Iowa has 2 different retrofit kits approved in our approved products list. So yeah, there's options available.
Great. All right. Thank you, everyone. Those were good questions. Appreciate them. I prepared some questions in case they were needed, and I think we didn't need them because we had a lot of good questions from the audience, which I'd much prefer. So I think we'll turn it over to the end now. The last things are, there are 2 remaining webinars in this series, as Kelly talked about at the beginning. The next one is about the Linker AT data tool that was developed under this project for conflating 2 different roadway network data sources. And then the last one is on freight data management. Those are coming up on December 7th and December 12th, respectively. And the URL is up there on the right for where to register, same location that you used to register for this webinar. So now that's it for me. If you want to wrap up.
Yeah, thank you everyone for attending today's webinar. I also want to thank our panelists. We had a great discussion here today. As I mentioned in the beginning, a recorded version of this webinar will be available on NOCO's website. On behalf of NOCO and our presenters, thank you for joining us today and have a great rest of your day. Bye-bye.